All right. Good evening, everyone. Good evening. One quick check with AV. Is everything good here? Yeah. Hey, Athar. Good evening. Good evening. Just give me one heads up with the AV here. Are we good? Are you guys able to see me and hear me? That's important, right? Hello, Rahul. Hello, Athar. Good, sir. All good. Yeah. Great, great, great. So we'll probably wait for a couple of minutes and then we should get going. Give me a sec. Right, I think we'll probably get started. We'll start with a topic on a weightage basis. It's not that important, but then as a conceptual understanding, this topic gets a little more a little importance than what it has on a weightage basis. The reason being that is we are dealing with quant, we are dealing with DILR. Some understanding about numbers is necessary. That's why number systems, number theory is super important when it comes to that part. The conceptual understanding needs to be there. On a broader scale, if I look at it on a weightage basis, we don't really talk about number system. You on your best day, you get 2 questions, not more than that. But if I think about other topics, when I put them under one shell, sometimes you get questions like how many values can n take, how many integral values can it take. Some of those question solving needs an understanding about numbers. On that ground, this topic gets super important. So let's roll with it and get started. To begin with, what are numbers? I want to go with the classification idea. What are numbers? Can anyone define numbers to me? What is the definition of numbers? Just quick idea. Any idea that you have as, oh, okay, that's how a number should be. What are numbers? Let me go in depth and add one more question. Are numbers really important? If you say yes, why do we need numbers? If you think, hey, numbers are important, if you say numbers are important, if you think about the fact that, okay, we need numbers, you might have to tell me why do we need numbers? What is the fundamental need of numbers? Yeah, Rahul says quantify. Exactly. In simple words, if I can put it around, I say to count. Man needed numbers to count. Numbers was a necessity to quantify anything. You cannot process a bunch of things today without having numbers. Despite the fact it is a subject that math is going to be little complex than the languages that we speak, there is no way you can ignore mathematics in your day-to-day life. To quantify, to begin with, quantification, comparison. In a lot of cases you need numbers. That's how man started using numbers. He needed numbers to count. He needed numbers to split. He needed numbers to divide. He needed numbers to add. He needed them to do the basic arithmetic operations. To begin with, counting. So it started there. He started counting it as 1, 2, 3, 4, 5. And then later on we added layers to it. Despite the fact the classification goes from a superset to a subset, man started with the subset. He started with counting numbers, then went to the other complex numbers. So we'll go gradually. To begin with, what is a superset of all numbers? If I say all numbers are dash and fill that blank, all numbers are what? What do you call all numbers? If all the numbers can be put under one roof and you can say all numbers, what is that system called? What would be that? Athav says basics, classification and divisibility basics, theory, and some 3 questions agenda. I have 6 in my mind. I hope we can get all 6. We'll cover all the basics and then we'll do some 5 to 6 questions. That's my idea. I'm just keeping my fingers crossed and we'll do it. To get back to the questions, Rahul says all numbers are integers. Let me think if all numbers are integers. Would you say if I write 4, do you call it an integer, Rahul? You would call it an integer. You should be calling it an integer. Will you call 0 an integer? Yes, sounds okay. Will you call -3 an integer? Yes, you should be calling -3 an integer. Will you call 4.7 as an integer? Is 4.7 an integer? Now comes real numbers. Varsha says real numbers. Meet Kadam says real numbers. Athar says rational. Now, people who believe, hey, real numbers is a superset of all numbers, then what is this? That's a number, right? So, all numbers are real numbers. Will you say, hey, all numbers should be real numbers now? Now, think again. Varsha and Meet, think if whether all numbers will be real numbers now. Will that be a case? Because I have I, which is a number, we call I a number, there is a representation of a number called I. Does it come under the category of real numbers? Sorry. Think again and say, this is called as an imaginary number. Now comes the question, hey, then all numbers are imaginary? No, some of them are real, some of them are imaginary. If I can put all numbers in one roof and call it a number, it's neither real or imaginary. Combination of a real and an imaginary number, we call it as complex numbers. That's the first idea. All numbers are called, all the numbers come under the subset called complex, or superset called complex. Complex number is written of the form a plus or minus ib, where a is called as your real part and b is called as your imaginary part. Now, a plus or minus ib, it can be a plus ib, it can be a minus ib. When I put b equal to 0, you end up with a, which is a real number. When I put a equal to 0, I will get ib, which is the imaginary part. Now, you are not tested on imaginary part when it comes to CAT. We are not going to look deep into imaginary numbers because that's not our agenda. That's not. But anything I do here, I can technically do here as well. So we get into real numbers. Now real numbers are further classified into 2 types. One is called as rational. The other one is called as irrational. Now we'll go to this later. What are rational numbers? What are irrational numbers? So someone brought this idea up. Athar said rational numbers and irrational numbers. What is a rational number? What is an irrational number? Can anyone define this idea of rational and irrational numbers? Anyone? Simple idea. Back then in school we studied any number of the form p by q where q is not equal to 0 is defined as a rational number. I never understood this logic. I've never able to wrap my head around this idea and say any number of the form p by q where q is not equal to 0. Sounds neat when it comes to a definition, but it didn't sit well with me. And then I started telling myself, if I can understand a number, that's rational. If I cannot understand a number, that's irrational. In a more significant way, I started saying, to give you an example, let me say 8.3. Let's start with this. Is 8.3 in your head? Take a guess and tell me. Is it rational or irrational? 8.3. Is it rational or irrational? I or R? Simply type I, R for your answers. If you say I, you say that's irrational. If you say R, that's rational. 8.3. Irrational have roots. Rational of the form P by Q, Q not equal to 0. Yeah, I'm getting all those answers. Varsha says 8.3 is rational. Varsha believes that she can understand 8.3. And she says that's rational. Fair enough. If I write 8.333, this is rational or irrational now? I or R? .33333. Now I, Varsha says I. Rahul says R. Srishti Srivatsa says R. Meet says R. Atharv says R. Okay. Varsha thinks that she is not able to understand. Varsha, think about this now. For all those people who said R, for all those people who believe it's I, never mind. Let's break it down. Now ask yourself this question. What is the first number, first digit after the decimal? What is the first digit after the decimal? You will say 3. What is the second place after the decimal? You will say 3. What is the third place after the decimal? You will say 3. What is the 10th place after the decimal? You will say 3. What is the 100th place after the decimal? You will say 3. I write it infinite times, you will call it 3. Why? Because you understand there is a pattern sitting inside it. I write 8.333 ... You understand, we don't assume, we understand that, okay, it keeps going 3, 3, 3, 3, 3, 3, 3, which means we understand that number, which means this is rational. So is this. We sometimes say, if I write 7.4632, I call this rational. Why? Because after the decimal terminates and it does not recur. Non-recurring and terminating. It doesn't repeat and it terminates. Non-recurring but terminating. If I write this in that format, I'll write this as, this is a recurring decimal but non-terminating. Non-terminating recurring decimal, non-recurring terminating decimal. These are the two types that we usually say. Even if it recurs, if it keeps going ... if I'm able to see a pattern, if it is a recurring pattern, I call it a rational number. It doesn't recur, it terminates, but all the digits are swapped. I don't care. If I know there are exactly 20 decimal places and I know all the 20 decimal places, that's a rational number. That will be a rational number. I don't care about what those digits are. If you can look at the number and then say, hey, this decimal place is this number, if you can understand the pattern and then figure it out, that becomes a rational number. Mathematically, any rational number can be rewritten as a fraction. Give me any rational number for that fact. You can rewrite it as a fraction. And to know how to rewrite a decimal to a fraction is utterly important. Sometimes you read a decimal, that ability to rewrite that as a fraction matters. It's a lot. Sometimes it works wonders. Looking at the pattern of the decimal and then saying, hey, this is the fraction that we are looking at. Super powerful idea. It works. Any rational number can be written as a fraction. Irrational numbers can never be represented as a fraction. For P by Q format, P and Q have to be integers. Super important. P and Q are integers. If I give you an irrational number, you can never rewrite it as a fraction. Right? For example, if I write 6.38472 ... Do we understand a pattern here? No, we don't. It's important that you know how to write a fraction, how to rewrite a decimal to a fraction. And for you to do that, the decimal has to be a rational number. Clear? Any doubts? One quick look at the chart here. Now quickly, one nice question that I have here is pi rational or irrational? Is pi rational or irrational? Quickly, nice question. What is the value of pi? Think. What is the value of pi? How do you write pi? Is pi rational or irrational? Athar says 3.14. I don't want. Fine. Is it I or R? Is it I or R? Athar says irrational. Rahul says irrational. It's non-terminating, non-repeating. What is the value of pi? In my school, or most of our schools, they taught us pi is 22 by 7. Right? P by Q format, P and Q are integers. Why do you want to call it irrational now? Rahul and Athar. Pasha also says irrational. Now pi value is 22 by 7, right? Forget about the decimal part. We were taught pi value is 22 by 7. Is 22 by 7 rational or irrational? Or let's put it this way, 22 by 7, rational or irrational? 22 by 7 is obviously rational, right? P by Q format, Q is not equal to 0, both of them are integers. This is rational. But pi is irrational. Now that puts us in a question, hey, two values are equal, one is rational, the other one is irrational. How is it even possible? Simply lies in the answer. They are not equal. They are approximately equal to. Back in school, your geometry classes, the questions had this. Assume pi equal to 3.14. It was never equal to 3.14. In fact, pi and 22 by 7, the only part that is equal in both values is 3.14. After that, pi is a different value, 22 by 7 is a different value. Check it out with the calculator. Pi is never equal to 22 by 7. They are close. They are equal only up till the second decimal, not more than that. 22 by 7 is rational, pi is irrational. Clear? Any doubts here? Any doubts? Awesome. Now, rational numbers are further classified, not classification beyond this. A subdivision of rational numbers are called integers. The numbers that are not integers, we call it fractions. The numbers that are integers and the other part is fractions. What are integers? Simple. Any number that does not have a terminating decimal point. 4.0, simple. 4, 7, 12, 23, all of them are integers. What are fractions? Fractions are other ways of writing a decimal number. Remember this, all integers are fractions. Not all fractions are integers. 4, I can write it as 8 by 2, which is fine. 8 by 2 is fine. Simplified value of 8 by 2 is 4. All integers are fractions, not all fractions are integers. Remember that. Integers is a subset of fractions, or in fact, integers is a subset of rational numbers. Imagine it this way. Any number that is an integer is a rational number. Anything that's not an integer is a rational number which is called as a fraction, which also follows the same definition, P by Q, where Q is not equal to 0. Fractions are further classified into 3 types. I'm pretty sure we all learnt it in our school. Proper, improper and mixed. Proper fractions, improper fractions and mixed fractions. Now what are proper fractions? Simple. Proper means numerator less than your denominator. 1 by 4, 2 by 7, 3 by 20, 99 by 100. If your denominator is greater than your numerator or numerator less than your denominator, simple. If the value is less than 1, if the fractional value is less than 1, we call it a proper fraction. Improper fraction, the exact opposite. Denominator will be lesser than the numerator, or in other language, if the value of the fraction is greater than 1, we call it an improper fraction. What is a mixed fraction? Mixed fraction is another way of writing mixed fraction. If I write a value like 4 by 3, you rewrite it as 1 by 3. What is 1 by 3? Simple. In simple words, we write it as Q R by D. What do you mean by 4 by 3? You are dividing 4 amongst 3 people. Your conventional division format will follow 4, 3 times, 1 time 3, remainder 1. This is called as your divisor. This is called as your remainder. This is called as your quotient. Q R by D is what we call it as a mixed fraction. 22 by 7, you write it as 1 by 7. Simple. It's a combination of, it is a sum of an integer and a proper fraction. It's a mixed fraction. So we all have learned this in our schools. We are just reiterating that part. Now integers do not have classifications any beyond, but there are some types of numbers under integers that we extensively use. Sorry. What are they? Can anyone tell me what are the types of integers? Not classification beyond this. This is also an integer. All these categories that we use in our day-to-day life are called integers. What are they? Most standard ones, whole numbers. What are whole numbers? Give me a second. Whole numbers and natural numbers. What are the difference between whole numbers and natural numbers? Simple. All the numbers starting from 1 till infinity, we call it natural numbers. They occur naturally. You can count all these numbers. But then later 0 was introduced and we made it a superset of natural numbers. All the numbers from 0 to infinity. Natural numbers 1 to infinity. Whole numbers 0 to infinity. Because 0 was invented, numbers were discovered. We often say this. Numbers are a discovery, 0 is an invention. 0 was brought in later. We invented 0. In fact, there is nothing such called as 0 as a number. You cannot count 0. How do you count 0? Think about this. I have 1 pen in my hand. If I have one more, you call it 2 pens in my hand. You don't call it 0 pens in hand. You call it nothing. And absolute nothingness has been termed as 0. 0 as a number, you don't count it, but 0 as an idea is super powerful. There are a lot of things in the modern day that you couldn't have achieved without the idea of 0. One of the most powerful inventions when it comes to math is 0. So remember that. So adding 0 to natural numbers makes it whole numbers. So the questions can have natural number format or whole number format. You have to understand what is being asked. Then followed by even numbers. What are even numbers? Any number of the form 2n, where again n is a natural number. Any number of the form 2n where n is a natural number, we call it even numbers. So we begin with 2, 4, 6, 8. You substitute n value 1 and then you start counting all the values. 2 into 1 is 2, first even number. Second even number 2 into 2, 4. Third even number 2 into 3, 6, and so on. But that puts us in the question, is 0 even or odd? Your first even number is 2. Your first even number is 2. Now comes to the question, 0 even or odd? What are your answers? 0, even or odd? Go for it. Saif says even. But 2 is your first even number. 2 is your first even number. Varsha says even. Then comes the next question. -2, -4, -6. Are they even or odd then? You say 0 is even. What about -2, -4, -6 and all? Will they come into the category of even, or do they come into the category of odd, or they don't have the classification at all? Athar says prime even numbers 2, 4, 6, 8. The question is not about 2, 4, 6, 8 anymore, Athar. It's about -2, -4, -6, 0. Do they have a categorization? Now, anytime people talk about even numbers or odd numbers, we always take it for understanding, take it for granted that we are talking about positive. When I say even numbers, I call 2, 4, 6, 8. 0 is even, -2, -4, -6, they all are called as negative even numbers, but we do not account for them. Because again, the counting idea started with positive integers, then came the negative integers and zeros and all. So those numbers do not take the definition by default, but -2 is even or odd, you call it is even, we call it an even negative number. Similarly, for odd numbers, we happen to have two n minus 1 format. All the numbers of the form 2n minus 1 will be called as odd numbers. Substitute n equal to 1, 2 minus 1, 1 is your first odd number. But then -1, -3, -5, -7, they are also called odd numbers, but we do not take it for granted from the word go. We call them negative odd numbers. But do they have a classification? The answer is yes, they do. Clear? Any doubts up until this point? 0 is divisible by 2. Okay. Next comes prime numbers and then composite numbers. What are prime numbers? What are composite numbers? What are prime? What are composite? Now this is where we'll jump to the next idea here. I'm going to go to the next part. We'll come here. What are prime numbers and what are composite numbers? We'll quickly have one definition on that and then we'll jump to conversions. Any number, the idea of prime says prime numbers has exactly two factors, whereas composite numbers, can anyone tell me the definition of composite numbers? Numbers that have exactly two factors are called prime. What are composite numbers? What are composite numbers? A lot of times I've heard people say any number that is not prime is composite. Numbers other than prime are composite. If there are only two categorizations that we talk about, anything that's not this becomes the other. The world has evolved around the idea of two options. One is this, the other one is that. Something that's not this is that. Something that's not a man is a woman. Something that's not a child is an adult. It's always this or that. But then there are some gray areas. Life is all about gray areas. So is math. So you cannot come to the assumption straight away that numbers that are not prime are composite, because there is a number called 1 which is neither prime nor composite. It's neither prime or composite. It doesn't come under the category of prime. It doesn't come under the category of composite, because numbers that have exactly two factors are prime factors, whereas composite numbers have more than two factors. whereas composite numbers have more than 2 factors, whereas 1 has only 1 factor, so it doesn't come under the category of this or that. Let's make it clear, okay? But let me bring this question. This is a trivial question. Sometimes it's important that we understand those simple tidbits. Let me ask you this. Minus 2. Is minus 2 prime or composite? This is something that we have never talked about. Most of us don't talk about this, but I wanted to like touch base with this idea. Beautiful idea to begin with. Minus 2. Now we know minus 2 is even. We have decided, we have talked about it and we have said, hey, minus 2 is even. We have fixed on that. So is minus 2 prime or composite? Go for it. Atharv says negative prime number. Varsha says prime. Okay. Now Atharv and Varsha, go back to the definition. Prime number has exactly 2 factors. Can you think about the factors of minus 2? What all numbers can divide minus 2? If I go to that, I'll happen to realize that 2 can divide minus 2, 1 can do, minus 1, minus 2. Minus 2 into minus 1 is, sorry, minus 2 into 1 is minus 2, minus 1 into 2 is minus 2. So they also happen to be factors. How many factors am I looking at? 4. Now let's ask again, is minus 2 prime or composite? Now Rahul says it looks like composite. Akshay has listed out the factors. Let me ask you this. Is minus 2 prime or composite? Your minds will say, hey, that looks like composite. Yes, it does look like composite, but it is not. It's not composite. Or do you think it's prime? It's not prime either. Or do you think it's unique number? No, it is not. How do I put it across? I can give you one nice example that we can understand this. If I ask you, let me name a few celebrities, some popular, not celebrity, some popular names in your head, or you can comment it down here. Tell me whether they are whether they come under the male category or the female category. So let's keep it this way. Okay, I'm going to give you 2 options, male or female. Okay, if I say Michael Jackson, you will put him under the male category. If I say let's say Cameron Diaz, put her under the female category. Michael Schumacher, male category. If I say Harmanpreet Kaur, female category. Sachin, male category. Dhoni, male category. Saina Nehwal, female category. You can classify them. Now what I want to do is this male or female? Is this male or female? Had I given you a transgender person and asked you male or female, you will say neither of this, but somewhere between this. The person comes into the classification, but they cannot be put into this classification like one. It's a simple idea. Now asking you whether this pen is male or female. What would your answer be? Do you have an answer here? Now, do you think it can come under one of the classifications? No. Why? Because for me to classify whether something is man or a woman, you have to be a living being. This pen is neither. Why? The pen is neither, not because it is a living being which doesn't sit in any of the category, because it is not even a living being in the first case. Same way minus 2. Minus 2 do not go into any categorization when it comes to prime or composite, because for you to determine whether number is prime or composite, it has to be a natural number, not even a whole number. Even 0 doesn't take that classification. The number has to be a natural number for that fact. We don't talk about minus 2, minus 3, minus 4. So prime and composite, this entire classification goes only for natural numbers. Nothing more, nothing less. Sometimes we know, hey, it doesn't come under a classification, but we don't know why. I think it's important to know why. Prime and composite is applicable only for natural numbers, not for anything else. Clear? Any doubts? Object, exactly. This is an object, more very specifically, not living. It cannot be put into a classification. Clear? Any doubts? Now, we'll quickly jump to this idea of, I told you, any rational number can be rewritten as a fraction. How do you do that? Now, to begin with, I'll start with the simplest. I'll start with a very simple number. How do you convert 8 as a fraction? I'm writing only 8. What is the way to rewrite 8 as a fraction? Multiple ways. I could have written this as 80 by 10 or 16 by 2 or 800 by 100, or I will simply write it as 8 by 1. Nothing complicated. You can rewrite it in any way. Quite simple. How about 8.3? How do you write 8.3 as a fraction? How do you rewrite 8.3 as a fraction? Simple, nothing fancy about it. 83 by 10. Right? If I write 8.3, I can write it as 83 by 10. If I write 8.33, I can write it as 833 by 100. But here comes the next question. 8.333 dot 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 dot. What is your way to rewrite this now? What is your way to rewrite 8.333333 and so on? I want to rewrite this as a fraction. How do you do that? Shall we do how it's done? Shall we see how it's done now? What I'm going to simply do is, I'm going to call this number A is equal to 8.333 dot dot dot. That's all. I'm going to call it a number called A. I'm going to name this A. Saif Chaudhary says 8.333 dot 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 divided by 10,1000 dot dot. Sounds nice, not right, correct. I need a prop infinity. Atharv says that's infinity. Let's see if that's how it's done. So what I'm going to do is, I'm going to multiply this number into 10. So what does it become? 10A is equal to 83.333, and then I'm going to take A as it is, 333 dot dot dot. Now can I say the decimal part here and the decimal part here happen to be one and the same? 0.33333333, 0.333333. The decimal part here and the decimal part here, they happen to be equal. Can we say that? What I want to simply do is subtract A from 10A. So what will I get? 9A is equal to this 0.333 here and 0.333 here will get cancelled out. Will be left out with 83 minus 8, which is 75. A is equal to 75 by 9, which I can simplify it as 25 by 3. Now pull out your calculators. Pull out your calculators. Do 25 by 3. You will get 8.3333 dot dot dot. Check it out. Any doubts? Any doubts? Any questions? Athar says no, professor. No for what? Am I incorrect, or you didn't understand, or you were wrong? Are we good here? Any questions? Any doubts? Should we do one more number? Or rather, we'll do it this way. We'll do it. Take a question. We'll do all three of them. I'll give you 3-4 minutes for you to think. Have a look at the numbers and then solve. I'm going to give you 2 minutes each question. Let's say 6 minutes in total. Let's see if we can get all three of them right. Rather than teaching you more questions, Let's practice them straight away. Atharv is asking, is 75 by 9 and 25 by 3 are the same answer? They are same. On the context of the question, you might have to swap your answers. You might get 75 by 9, but the options might have 25 by 3. So you might have to simplify it for that case. The answer is wrong, you put 75 by 9, you will still get 8.3333. The value doesn't change. The option might, depending on the question. Right, we'll do them one at a time. I'm going to do first one. I'm going to say A is equal to 2.44. Simple, it's not even a term, a recurring decimal. I can simply write this as 244 by 100 straight away. I know terminating decimals, sorry, non-terminating decimal. I'll straight away write it as 244 by 100, might as well. If I want to simplify it, goes well in 4. 61 times 25, 61 is prime, so 61 by 25 is your right answer. Good going if you have gotten 61 by 25. Second one is 0.121212. I'm going to say A is equal to 0.1212. Now, we saw that in the previous question, the idea is to retain the decimal part as the same part. Now, will I multiply it by 10? If you multiply this by 10, look at the case here, case in point here. 10A is equal to 1.21212 dot dot dot. If I subtract A from this, you will get 0. You'll happen to get 0.121212. Now, if you look closely, are the decimal parts same in both cases? No. So will I do it this way? Shouldn't be doing it this way. So what I'm going to simply do it, instead of multiplying it by 10, I'm going to multiply it by 100. 100 is equal to 12.12 bar. Instead of putting dots, if I put a bar over the number, it means the same, recurring. The bar on what numbers signify which part is recurring. If I write 12.12 bar over 2, which means 12.12222222. This means 12.12121212. Be very careful where the bar is setting. So sometimes out of laziness, I write it this way, which is not incorrect. Here I'll write A is equal to 0.12 bar. Now the recurring part is same. I can happily simplify this now. If I write minus here, 99A is equal to, I can cancel the decimal part here. I'll happen to get 12 minus 0 is 12. A is equal to 12 by 99. I can cancel it out in 3. This will become 433, which is 4 by 33. And that will be your answer. 4 by 33, 12 by 99, doesn't matter. It's 0.12121212. Simple. If I come to this 7.43333, I want to say A is equal to, let me not write A everywhere. I want to say C is equal to 7.43 bar. Now the bar is over 3, which means I want to retain the 3-part repetitive part after the decimal. So what I want to do is first, I want to write 10C is equal to 74.33 dot 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 dot. Right? What else can I do? I cannot subtract C from here because this is 43333, this is 33333, cannot work. So what I want to do is I'm going to multiply it by another 10. So 100C is equal to 743.333 dot dot. I subtract this, 90C is equal to 743 minus 74. 43 is gone, 700 left out. 43 means 31 is there. If I subtract 31, 661, am I right? 661 plus, oh sorry, 669 if I'm not wrong. Uh, 643 minus plus, sorry, 26, 669, my bad. So C is equal to 669 by 90, right? Want to simplify it? Simplify it. You simplify this, I can do it in 3. This will be 223 by 30. I don't think 223 gets divided by any other number. It's a prime number. It's 669. Yeah, thank you. 223 cannot be divided further. 221 is 13 into 17. 225 is 25 square. I don't think any number divides 223. No. So that's your answer. Any doubts? Are we good with converting fractions, decimals to fractions? Any doubts? I'm going to have one look at the chat here. Are we good? Yes? No doubts? Awesome. I'll quickly jump back, do a few ideas and then come back to this. Now the moment we talk about prime and composite, we already mentioned prime, exactly 2 factors, composite, more than 2. Now if I give you a list of numbers and I ask you, hey, whether they are prime or composite, if I ask you, if I list them down and if I ask you to rate it prime or composite, I think it's a pretty simple task, right? If I say, let me write down a bunch of numbers, 2, 8, I'm gonna go 16. I don't want 16. I'll have 8. And then we'll have 15. And then we'll have 75. And we'll have 36. We'll have 16. We'll have 18. And then 1. What I'm going to do is, I'm going to give you 2 minutes. I've listed down 8 numbers here. I want you to rate them either prime or composite. P or C. P, C. Prime, composite. Okay. You can put it in the chat box here. Simply put PC, whatever it is in your head. We'll list them down. We'll think about it. Okay. Mansi says only 2 and 1 are prime. Mansi, are you sure that only 2 and 1 are prime? There's no 87, that's 81. I'm sorry, oops, if my handwriting is bad, that's 81. Even in that case, are you sure 87 is prime? You said 2 and 1 are prime. Are you sure 2 and 1 are prime? Only 2, exactly. I think we all were able to understand, hey, this is prime, this is composite, all those ideas. But the underlying idea question that I have is, how did you spot the prime and composite? For example, you said 2 is prime, fine, understandable. How did you know 8 is composite? How were you certain of the fact that, hey, 8 is composite? Anyone who answered 8 is composite, how do you know that 8 is composite? On the basis of factors. Varsha says on the basis of factors. How do you know 8 has factors, Varsha? And I'll ask you questions until I get the right answer. Sometimes giving out the answers is not the best way to learn something. I believe in asking questions. Because it has multiple factors. Mansi says it has multiple factors. How do you know it has multiple factors? Will be my next question. All even numbers except 2 are composite. Rahul says all even numbers except 2 are composite. Fine. But you said 15 is composite. You said 75 is composite. You said 81 is composite. They are not even numbers, but you call them composite. How were you certain of that? Those are not the right answers. I don't know. Sometimes I talk a lot about muscle memory. The ability to do something over and over and again, infinite number of times, at a certain point in time, we don't really understand how powerful our mind is. It does a lot of things without us giving it inputs. For example, think about this. I don't know if I've given you this example, but this is one example that I repeat over and again. Imagine riding a bicycle. One of the most powerful muscle memory things that I've understood is riding a bicycle. We believe that we ride a bicycle. No, at a certain point, your mind knows how to do it. Your mind knows. It does. Think about it this way. If you ride a cycle or a bike for that fact, what is the first thing that you do when you have to turn left? Now let's say you are in a left turn in a cycle. The cycle is more relatively easier to understand. When you have to turn left on a cycle, what do you do? What is the first thing that you do? Of course, a lot of people believe that, hey, I turn the handle, I tilt the handlebar. That's not the only thing that we do. What else we do? Subconsciously, our body does this. What is that? Have you noticed this? Next time you ride a bicycle, probably you can experiment this. When you tilt your bicycle, your handlebar, your hand tilts the handlebar, but your body somehow puts the weight a little towards the right. Have you noticed this? Your mind knows when you turn left, you have to slightly put your body to the right. Do you know that? Have you realized this? Why? To maintain that center of gravity. Your body knows it. Lift a heavy bucket. When you lift a heavy bucket, you put your weight towards your other side. Why? So that your center of gravity is kept straight. You maintain it. Super. Our body subconsciously does it, and I think that's a very powerful mechanism in our head. Sometimes we know we are doing it and we don't realize it. All of you said these are all composite. You said 8 is composite, I will give it to you, even number. 36, 16, they all are composite because they are even numbers. But somewhere deep down, you also realized 81 is composite. You thought 75 is composite. You thought 15 is composite. And you didn't think of why. You said it's composite. Our mind subconsciously does something. Did you realize it? That is what I call it as. I call this idea as our mind silently does. Our mind subconsciously does this test to numbers called divisibility tests. Your mind does it. I don't care about fine. 8 I understand, 36 I understand, 16 I understand. You thought these numbers are also composite. Your mind automatically said that. Now if I write 147, your mind will say whether it's prime or composite without even realizing it. And that is what I call it as divisibility test. All this while your mind has been doing divisibility. All this while. Now if you recollect it, you will be like, yeah, that's what I was doing. Do you recollect it now? Yes. Bucket Wallah. Happens, man. Now, people say they are very weak at math, but when you go to a shop, when you do a cash transaction, you exactly understand the transaction over there. You don't need a calculator. You have gotten so used to it. You have gotten the ability to understand. Sometimes I talk about this also. Think about it in this way. When you are hungry, when you are ravenous, you don't account for how much you are going to eat. But sometimes your mind, by looking at a plate, by looking at the food that is being offered, you know whether it is sufficient or not. Your body knows it. A lot of things your brain understands it even without giving it an input. It doesn't need an input there. It automatically computes that idea and then says, hey, this is what needs to be done. A lot of places this happens. Mathematically, here in this case, your mind is silently doing something called divisibility tests. And divisibility tests are utter important when it comes to number theory now. You have to understand all the divisibility tests. I'm going to run through all the important numbers divisibility ideas. Conceptually, we'll run through it so that you can have one grasp of what they are. Now, tell me what is a divisibility test of 2? What is the divisibility test of 2? Simple. All you do is you look for the last place. Right? You will write for the last place. You just look for the last place and you see whether the last place is divisible by 2. If it is divisible by 2, you say, hey, the entire number is divisible by 2. If I write a number like 6387 4258765482324 and ask you whether the number is divisible, whether the number is prime or composite, you don't even spend a second and then you say, hey, the number is composite. And how do you do that? You didn't even look at this entire number. All this while my energy was an utter waste because all you had to do was focus on this number. Look at the last number, hey, that's 4, that's composite, right? So that's what 2 does. 2 says, look at the units place. If it is divisible by 2, the number is divisible by 2. If it is not divisible by 2, the number is not divisible by 2, period. This is what we learned. I want to break it down a little further and ask you, do we know why we are doing this? Do we understand the idea behind why this property has been used? Simply, it starts with this fundamental way of writing a number. When I say expand 638, or if I say expand 636, how do you write 636? You write it as 600 plus 36 plus 6. If I ask you to expand it to its face value, you will write it as 6 into 100 plus 30 into 6. I wrote 36, my bad. 3 into 10 plus 6 into 1. If I ask you whether 636 is divisible by 2, is it divisible? The idea starts from here. I want to check whether this number is divisible by 2. I'm thinking, hey, is this number divisible by 2? Is 100 divisible by 2? Yes. Anything multiplied by 100 is divisible by 2 then. Then do I have to check for this part? Do I have to check for this part? No. Is 10 divisible by 2? Yes. Any number divisible multiplied by 10, is it divisible by 2? Yes. Do I have to check for this part? No. Is 1 divisible by 2? No. Any number multiplied by 1, will it be divisible by 2? I am not sure. That depends on what number you are multiplying. That is why I look only for the last place. That's how the idea has been generated. If 10 is divisible by 2, any other power after 10 is divisible by 2. So you don't have to check anything from here. The only thing that I need to check is for the units place. And that's what the rule also says. Check only for the units place. Nothing more. You don't have to do anything more than that. Clear? The same idea is being used for another number. Can anyone tell me what number that is? Same idea. Same idea. Ditto same idea is used for another number. Can you guess what number that is? Varsha says 4. Varsha says 4. Do you check only for the last place for 4, Varsha? Think. I do the same for 5. What do you do for 5? If I ask you, is this divisible by 5? What will you say? Simply look at the last place. You say that's 5, and then you'll say, hey, the number is divisible by 5. If I say, ask you whether 636 is divisible by 5, you'll be like, no, last place is 6. 6 does not get divided in 5. So 636 is not divisible by 5. So 5 also uses the last place concept. One more number uses the last place concept. Can you think what number? Divisibility rule depends on the last place of a number. Can you tell me one more number that also uses the last place concept? 2 does, 5 does. There's one more number. Exactly. 10 also does the same idea. For 10, you check for the last place and it has to be 0 only. But as any other number in the units place, I'll happily say the number is not divisible by 10. So 2, 5, 10 depends on the idea of the units place of number. It relies on the units place. The units place is divisible. The number is divisible by 2, 5 and 10 respectively, depending on the number that we are talking about. If a number is divisible by 10, it is divisible by 5, it is divisible by 2. So we understand, we go a little up and down every now and then, right? Now can you tell me the divisibility rule of 4? Now Varsha just said it. Divisibility rule of 4. Same. You have learnt it in school. Simply you are looking at the last 2 places of the number. Now why last 2 places of the number? comes with the same idea. 100 is divisible by 4. Anything multiplied by 100 is divisible by 4. So I will not check for 100 or anything beyond 100. Do I have to check for 100? No, because 100 is divisible by 4. 1000 is divisible by 4. 10,000 is divisible by 4. They all are divisible by 4. The only places that are not divisible by 4 are 10 and 1. So that's why I have to check for the last two places of the number, and that is what the property is. Check for the tens place and the units place. They are important. You crack for the tens and the units place, you look at a number, you say, hey, the tens place and the units place together are divisible by 4, the number is divisible by 4. If I write a number like 6387426884224 and I ask you whether the number is divisible by 4, I just look at 24 and then I say, hey, 24 is divisible by 4. This entire number is divisible by 4. Done. Case closed. I don't have to do anything more than that. Clear? Now, the same idea is being used by another number. Check for the last two places. If the last two places are divisible by this number, the entire number is divisible by this number. Which number are we talking about here? The last two digits of a number should be divisible by 4 for the number to be divisible by 4. The last two digits of the number should be divisible by x for the number to be divisible by x. What is that x? No prizes for guessing. 25. If I ask you 645 is divisible by 25, you look at 45 and then you say, no, 25, 50, 75, 0, 0. 45 doesn't come in that. 645 is not divisible by 25. If I write 6748575, is this divisible by 25? I look at 25 and then say, hey, this number is divisible by 25, right? Because the last two places are 72. So 25 also takes that rule. One more number takes that rule. Can anyone tell me that? One more number takes that same rule. Last two places should be divisible by this number for it to be divisible by that number. What is that number? Think. One more number gets applied here. Which number are we talking about? Once again, no prizes for guessing. 100 also you do the same trick. Last two places have to be 0, 0 for a number to be divisible by 100. Same idea. Now, are we cracking a pattern here? 2 last place, 4 last two places. Can anyone guess for 8 then? Can anyone guess for 8? What would be the logic for 8 now? Simple. Last three places then. Hundreds, tens, units. 2 power 1, 2 power 2, 2 power 3 and so on. Same logic for 5 powers and 10 powers. So what will be the divisibility rule of 16? Check for the last 4 places. That's all. We do it, we are through. Clear? Any doubts? Are we good with this? Here comes 3 then. What is the divisibility rule of 3? What is the divisibility rule of 3? Someone wrote it some time back. Divisibility rule of 3. Rahul said 50 for, I guess for the last two places. No, 50 will not work. Sum of the number. Mansi, you have to be a little more specific. You cannot say sum of the number. Make it a little more clear. Sum of the digits of the number should be divisible by 3, precisely. For example, if I write, let's say 741, and I ask you whether the number is divisible by 3, all we simply do is 7 plus 4 plus 1 is 12. 12 is divisible by 3. The number is also divisible by 3. That's the property. Again comes from the same idea. So I'm just breaking it down. All these ideas come from the expansion, the face value representation of number. So how do you write 741? 7 into 100 plus 4 into 10 plus 1 into 1. Or I can rewrite this. Now for the previous case, 10, 100, 1000, 10,000, they were all divisible by 2, 4, 8, 16, so on and on and on. But we understand that anything that I write here, 1, 10, 100, 1000, 10,000, lakh, 10 lakh, none of these numbers are divisible by 3. So how do I represent, how do I rewrite this? I want to rewrite this in a way where I can cancel them out in some comfort. So 100, how can I write 100? What is the closest number to 100 that is divisible by 3? That we all know. 99. Can we write this as 99 plus 1? Yes. Plus 4 into, what is the closest number to 10 divisible by 3 again? 9. Can I write this as 9 plus 1 plus 1 into 1? So we can multiply this inside. 7 into 99 plus 7 into 1 plus 4 into 9 plus 4 into 1 plus 1 into 1. I'm breaking it down to a comfort level for me to compute it now. 99 is divisible by 3. Any number multiplied by 99 should be divisible by 3. So do I have to check for this now? Nope. 9 is divisible by 3. Any number multiplied by 9 is divisible by 3. Do I have to check for this part? No. What else is left out? 7 into 1, 7. 4 into 1, 4. 1 into 1, 1. I'm adding only these 3 parts. And then checking whether that is divisible by 3. That's where the logic comes. Sum of the digits should be divisible by 3. It says sum of digits should be divisible by 3. Now there is one more number that works on this logic. What is that? There is one more number that also works on this divisibility rule. 9 it is. 9 also operates on the same idea. Sum of digits should be divisible by 9. Look at the same 99 and 9. All of them will get cancelled. You will be left out with the remaining parts. Same formula. Not same formula. Same property. Same rule. Clear? Any doubts? Are we good here? First I was asking, is it 9? Yes, it is 9. So we are done with 2, we are done with 3, we are done with 4, we are done with 5, 6. What is the divisibility rule of 6? What is the idea behind 6 now? What idea do we stick behind 6? What would it be? What is the divisibility rule of 6? Can anyone point it out? Anyone? All our life in our school we have said that, hey, for 6 you have to check for 2 and 3. Every time I ask people, they tell me, sir, 2 into 3 is 6. That's why we check for 2 and 3. I leave it at it. I don't really touch behind that. We'll see if it is true today though. All through your lifetime, all in your school days, your high school, your engineering or non-engineering, your UG, anywhere if you have come across, no one would have never taught you the divisibility rule for 7. Is there a divisibility rule for 7? Yes, there is. But it is always good that it is left behind. You don't follow the divisibility rule for 7 because it is slightly lengthy and tricky. What do I mean by tricky? I can give you an example. Let's say 343. I want to know whether 343 is divisible by 3, right? So the idea says multiply the last place by 2. Multiply the last place by 2 and subtract it from the remaining number. So 3 2s are 6. So subtract 6 from the remaining number. 34 minus 6 is 28. Is 28 divisible by 10? Sorry, 28 divisible by 7? Yes, it is. So this number is also divisible by 7. We can nicely say that. This is the rule. We'll apply it for 741. Same idea. 741. Multiply the last place by 2. Subtract it from the remaining number. 74 minus 2 is 72. Is 72 divisible by 10? No, sorry. 72 divisible by 7? No. 741 is also not divisible by 7. When you get the remaining part, check for the divisibility of 7 for that number. If it works, the original number works. If it doesn't, the original number doesn't. Sounds like a very beautiful idea. Why don't we follow it? Simply because if I give you a number like 6384718, I ask you to check for the divisibility of this number. Now it's a bit painful. Into 2, subtract 16. And then you'll say 6384705. And then into 2, 10. 638,460. You have to keep doing this over and again. So a simple way, I would rather divide it by 7. So that's the reason behind it. So 7 has a rule. No one teaches you 7, and it is good that it's not taught. I sometimes tell people, know what, know why, know how. Sometimes it's good that you leave it alone. You don't follow that for your life. You know there's an idea, but you don't follow that idea, right? You know there's a team called RCB, but you don't support it. Like that. You know the team exists. It's better left alone. You don't really poke your head around RCB and say RCB all for life. No, just let it be. As simple as it goes. Right. Any doubts? Any doubts for 7 now? Any questions? We'll jump to the next one. So 6 done, 7 done, 8 done, 9 done, 10 done, 11. What is the divisibility rule of 11? I'm going to break down the rule idea as simple as it can go. The idea simply says sum of odd places minus sum of even places. Now there are a lot of times that people say difference between the sum of the alternate digits should be 0 or a multiple of 11. That's how they say it. The difference between the sum of alternating digits. But I stick with sum of odd places minus sum of even places for one major reason. I follow an idea behind it and I stick with sum of odd places minus sum of even places. You do sum of even places minus sum of odd places. I'm not telling you it's wrong, but I'm telling you if you follow this method, it helps me in one other concept, so I stick with this. I'll tell you why I follow it when we do the next class. But for now, sum of odd places minus sum of even places. What does it mean? If the question says 7432, all you do is add the alternating digits. 2 plus 4 is 6. 7 plus 3 is 10. 6 minus 10 is minus 4. Minus 4 is not divisible by 11. So the number is also not divisible by 11. Now you can also do 10 minus 6. Mind you, you can also do 10 minus 6. 4 is not divisible by 11. The number is also not divisible by 11. I tend to stick with 6 minus 10. For a very major reason that I follow. Mathematically, this is more appropriate than this. The divisibility idea has one more concept sticking to it. For that, following 6 minus 10. From the right, you always add from the right. If I get a number like 14684, this is not a problem. You start from right or from left, it is always 1 plus 6 plus 4. Not a problem. But if you get 6387, 10 minus 14 and 14 minus 10, 10 minus 14 is more appropriate. I am not saying 14 minus 10 is incorrect. I'm saying 10 minus 14 is more appropriate. Why is it more appropriate? I'll tell you about it when we do the next class, when there is another idea sticking to it, right? Any doubts? 12. What is the divisibility rule of 12 now? What is the divisibility rule of 12? Quickly. How do I check whether a number is divisible by 12? Anyone? Varsha says, is it divisible by 3 and 4? Why did you take 3 and 4, Varsha? Varsha says 3 and 4. Why 3 and 4? Why do you have to go with 3 and 4? Anyone else? Anyone can anyone point out what is the divisibility rule of 12? Should you do it with only 3 and 4? Or do we have other ways to check for it? In your mind, if you think about it, has to be 3 and 4 because 3 into 4 is 12. Why can't we do 2 and 6? Because 2 into 6 is also 12. Right? No idea. It's okay. You could also do 2 and 6, right? Why are we not doing 2 and 6? You think, sir, again for 6 you have to do it for another 2 and 3? It's not about how many steps we do. We are only worried about whether the steps are correct. For doing one more step, even if it's right, you can follow it, right? Should we follow 2 and 6 or 3 and 4? If you think about, if you realize that, hey, 2 and 6 also is right, 3 and 4 is also right, check this out. If I have to check for the divisibility of 18, 18 is divisible by 2, 18 is divisible by 6, 18 is not divisible by 12. So a number that is divisible by 2, a number that is divisible by 6 was not divisible by 12, right? If I take 24, 24 is divisible by 2, 24 is divisible by 6, so 24 is divisible by 12, and 24 is divisible by 12. Sometimes it works, sometimes it doesn't work. But with 3 and 4, check this out with 3 and 4. Anytime 3 and 4 agrees, every time 3 and 4 agrees, 12 also agrees. Anytime 3 and 4 agrees, 12 also agrees. So is it 3 and 4 or 2 and 6? It is 3 and 4, not 2 and 6. But how do I decide? If I ask you for 24, should it be 2 and 12, 3 and 8, 4 and 6? Which one would I pick? Which one should I pick? For 24, should it be 2 and 12, 3 and 8, or 4 and 6? Which one should it be? It has to be 3 and 8. 2 and 12, 4 and 6 do not work. How do I decide that? Simple. 3 and 8 are called as co-primes. Let me introduce you to a new word in case if you haven't, called co-primes. What are co-primes? Two numbers are said to be co-primes when the highest common factor between them is 1. They share no factors between them except 1. 2 and 12 HCF is 2. 4 and 6 HCF is 2. That's why I don't choose these two. I choose 3 and 8 because 3 and 8 have only one factor in common called 1. Now quickly, 72. What do you check for 72? Which numbers would you check for 72? The product of the number should give you the number. The product of the two numbers should be coprimes. That's the only condition that you have to look for. So what is the divisibility rule of 72? I have to check whether a number is divisible by 72. How do I check it? What will be the divisibility rule for 72? What numbers should I check for? Exactly, Vasha, absolutely right. 8 and 9. No other combination works, only 8 and 9. Break them down, look for which factors together makes the product of 72, and they should have no factors in common except for one. They have to be coprimes. Clear? Any doubts? Any questions up until now? We'll crack a couple of questions on this idea now. Check which of these numbers are divisible by 11. Which number is divisible by 11? So quickly, which of the following numbers is divisible by 11? I simply look for the digits. 1, 2, 5 is 8. 3 and 4 is 7. 8 minus 7, 1. So no. 3, 8, 7 is 18. Minus 3 is 15. No. 4, 2, 4, 8 is 14. 9 plus 6 is minus 15 is minus 1. No. 7, 8, 9 is 24. 1 and 1 is minus 2. 22. 22 is divisible by 11. So D is divisible by 11. Nothing fancy. Simple ideas that you work with. Right? How about this question now? Go for this. This question has one nice added layer to it. So go for it. Akash is asking how many squares, cubes, tables should you know to do good in CAT? I do not ask for much. If you know how to multiply numbers from 1 into 1 to 9 into 9, I think this is a bare minimum that I tell anyone. Starting from 1 into 1 to 9 into 9, know them how to square it, how to multiply numbers. Even bigger numbers can be multiplied. I am not a big fan of speed math when it comes to CAT. I am a very big fan of speed math. I love doing math super fast. There are times where I go overboard to impress a bunch of people. I walk to a shop, to a grocery shop, the storekeeper would write down all the numbers and he will be adding by places, and then I add them and then straight away send the money and I'll be waiting for him to finish. Shopkeeper goes like, okay, how did you do that? I like that attention. I'm not going to lie. We all love that, right? Someone does something great and you're like, oh, how did you do this? We all want to be in that spotlight for at least for a minute. The sense of appreciation has gone down. For me, this is one issue, right? In my general life or in other places, I am a big fan of speed math. But when it comes to CAT, I do not really emphasize a lot on speed math, but I tell people to emphasize on calculation speeds. Now, these are two different ideas. I'm not telling you do Vedic math, abacus, you have to do all of this only to excel in CAT. Absolutely not necessary. You can have zero experience in abacus and speed math, Vedic mathematics, and still can do good mathematics here, do good calculations. There are a few tricks and tips that I follow, which I will give it in classes every now and then. Every time I come in, there are a few ideas. I can square 2-digit numbers in less than a second, faster than calculators. It takes 4 seconds to square a 3-digit number. There are a lot of tricks that you can follow. I tell them to know them, not to excessively follow it, because you do have a calculator to square, cube and all. But a strong recommendation, I tell people you should be good enough to square 1 to 24 at least and 1 to 15 cubes. I sometimes tell these are bare minimum. Sometimes you look at a number, you should be able to say, I know this number. I look at 243, my mind should go, that is 3 power 5. I am that kind of a person who will say, you look at a number, 6561 is 81 square, which is 9 power 4, which is 3 power 8. You should learn how to break it down. That is an added bonus. That's not your primary weapon to deal with. That's an added bonus. I recommend people to build it. Sometimes I tell people it comes naturally. The more you solve, the better you will learn them. So you need them, but as a bare minimum criteria, this is what I tell people. This is my bare minimum criteria. For you to answer your question, this is what it is. I am the Kratos of Quants. I'm glad people know about Kratos. Kratos has been my favorite fictional character for 21 years now. For 21 years, I've been a big fan of Kratos. It's weird some people point out to Kratos. Am I the Kratos of Quants? Absolutely not. I take that compliment, but with all humility, this is a few things that I do. There are people who do better. It's good to know them. It's good to do them. And it's always I'm always happy to share it with you folks. We'll talk about this maybe a class or two on speed math that I know that I can teach you. Right, what is the answer for this question now? Parsha and Atharva are asking, is it 5? I don't know. Might have to work around it. We'll see. What is the smallest number to be added? 7, 4, 5, 6, so that it becomes divisible by 9. We know the divisibility rule of 9. It says that 7, 4, 5, 6. I'm going to say 7 plus 4 plus 5 plus 6. 11 and 11 is going to be 22. Is 22 divisible by 9? No. What could be added to 22 such that the number is divisible by 9? 5. Yes. Now understand this. 5 is the number that can be added to 22 to make it divisible by 9. But we could have added 7, 4, 5, 6 plus 500, right? It needs a 5, that's all. It needs a 5. I can add that 5 here. Yes, it would have become 7, 9, 5, 6. Isn't it? 7, 9, 5, 6, add 7, 9, 5, 6, what do you get? 18 plus 9 is 27. 500 works. 7, 4, 5, 6 plus 50. I could have added 50. I would have gotten 7506, which is 18, absolutely divisible by 9, would work. I could have added 7456 plus 5000. That would have taken me to 12,456. I add all of this, I'll happen to get 18 again. Yes, again divisible by 9. Remember this, 5 needs to be added to the sum of the digits. But 5 is not the number that you'll add to this number. Not necessarily. It could be 5, 50, 500, 5,000, 50,000. It could be anything. But the question clearly says, what is the smallest number that needs to be added? The smallest number that needs to be added. Among these numbers, which is the smallest that I can add? Clear? Any doubts? Are we good with this? Any questions? It can be 5, but here the answer is 5 because the question is asking for the smallest number. You could have added 50, you could have added 500, you could have added 5,000. It will still work. It will still work. But since the question asked for the smallest number, the answer is 5. Clear? Any doubts? Are we good with this? One more question. Go for this. Akash is asking, I'm a pro MBA student. I think for the pro batch, yes, the pioneer batch is available, but I'll just verify with people. You can reach out to the people that you have been talking to. But I think yes, pretty much. For pro batches, the pioneer batch will also be available. The English pioneer batch is also available. That's the least that I know, but I don't want to give you my word. Just check with people. I'll also get back to you once I get a confirmation. Pro batch will, Rahul says pro batch will have access to pioneer English. Yeah, that's what I think I also heard, but I don't want to give you, I don't want to mislead you with information. But since if you have the information already, well and good. I'll just check and get back to you. A few sessions on speed math. I don't take sessions on speed maths. I add those layers in between my questions, in between my topics. Because speed math as a topic is not so relevant. I don't give it a lot of relevance when it comes to CAT. Once again, I tell people for competitive exams like MBA competitive exams, you don't really need speed math. If you are appearing for bank exams or other exams, speed math is utterly important, super important. Here you can get through it even without knowing it. That's why I added as layers in between topics. We'll talk about it. But I'll do this question now. Find the smallest number greater than 1000, which is divisible by 12 and 15. A simple idea that's being added. I am looking for a number that is divisible by 12, also divisible by 15. Instead of looking at numbers divisible by 12 and 15 separately, I can simply say, hey, let me take the LCM of 12 and 15, which is 60. Any number that is divisible by 60 is also divisible by 12 and 15. Why did I take 60? 60 is the first such number that will satisfy for 12 and 15. We call it LCM. We'll get in depth about HCF and LCM in the next class, the forthcoming class. But for now, we are just looking at divisibility rules and factors, multiples. Just take this idea alone, right? So 60, a number that is a multiple of 60 greater than 1000. And I need the first such number. So what are the multiples of 60? I can take 600, add another 300 to it, add another 60 to it. That will take me to 960, which in terms 60 into 16 is 960. But they are asking greater than 1000, which means I'll take one more. 60 into 17 is 1020, and that is the first number that will satisfy both 12 and 15. For 12 it will be a separate number, for 15 it would have been a separate number, but for both of them 1020 is the first number. So the answer is 1020. Clear? Any doubts? Are we go to the basic idea here? This is the utter basic idea that you need to know. Divisibility rules, co-primes, integers, fractions, conversions, rational, irrational. All these are the elementary ideas, utter basic for any other topic as well, again, moving forward. So get to know these. In the next class, we will talk about in depth about factors and multiples, number of factors, sum of factors, product of factors, HCF and LCM, questions based on HCF and LCM, HCF LCM properties. This we'll be doing this in the next class. Before that, run through all these questions once we finish, solve the DPPs, have an idea. If you're not able to solve the last 2-3 questions in the DPPs, we'll cover it up in the next class. When we do some topics from the next class, that will cover it up for the DPPs. So don't worry about that, right? Alright then folks, we'll wind up here. The remaining questions, we'll discuss it in the next class. What about the other questions? Varsha is asking, can we do this question as the number greater than 1000, which is divisible by 3, 4 and 5, instead of taking LCM? Yeah, same. Number divisible by 3, 4 and 5 is again LCM of 3, 4 and 5, which is 60 again. How is it any different? Same. LCM of 12 and 15, LCM of 3, 4 and 5, they both are 60. So you are doing it, I did it this way, you just went a little around to touch 60. Are you wrong? No. Is it a breakdown of this question? Yes. What about the other questions? Athar will stop here because the other questions we have to deal about factors, and we don't have time to work around factors now. We have spent quite some time. Next class we will cover it up. Factors, multiples, HCF and LCM will be for next week. Not next week, the forthcoming Saturday. We'll do it then, right? Well then folks, it was nice catching up with you. Have a great week ahead. Thank you. Good night folks. Good night. Thank you. Thank you.